Hello everybody and welcome to another FHM Network Academy training video. I'm Salsan Farahman and I'm so honored and grateful to be with you in this training video. After talking about data transmission in previous video, in this video we will talk about network topologies, which are very important to know before going further in our video series. Let's get started. What are network topologies? First of all, I would like to answer to these two questions. The first one is what is network topology? And the second one is why is network topology important? Network topology refers to how various nodes, devices, and connections on your network are physically or logically arranged in relation to each other. Think of your network as a city and the topology as the roadmap. Just as there are many ways to arrange and maintain a city, such as making sure the avenues and boulevards can facilitate passage between the parts of the town getting the most traffic, there are several ways to arrange a network. Each has advantages and disadvantages, and depending on the needs of your company or your network, certain arrangements can give you a greater degree of connectivity and security. Now, why is the network topology important to us? The layout of your network is important for several reasons. Above all, it plays an essential role in how, or better to say, how well your network functions. Choosing the right topology for your company can increase performance while making it easier to locate faults, troubleshoot errors, and more effectively allocate resources across the network to ensure optimal network health. Choosing a right network topology can increase energy and data efficiency, which can in turn help to reduce operational and maintenance costs. There are two approaches to network topology. Physical and logical. Physical network topology, as the name suggests, refers to the physical connection and interconnections between nodes and the network, the wire, the cables, and so forth. And logical network topology is a little more abstract and strategic, referring to the conceptual understanding of how and why the network is arranged the way it is and how data moves through it. As I mentioned before, topology defines the structure of network and how all components are interconnected to each other. In another word, network topology is the physical layout of computers, cables, and other components on the network. There are lots of different network topologies out there, but the most important ones are bus topology, ring topology, star, and mesh. When we talk about network topology, we describe the physical layout or physical topology, and then we have to talk about logical network topology or the access method. So what is access method? Access method is a set of rules governing how computers access the media or access the network. In some topologies, physical network topology is the same as logical network topology. How the components of our network connected together is equal to how they logically access to the media and connect together. But in some topologies, the physical layout of the topology is completely different from how they access to the media and the logical operation that happens for components or computers to access to the media. Okay, let's talk about the first one, or bus topology. In bus topology, all stations are connected through a single cable or backbone. As you can see on the picture, all these 5 nodes are connected to the same bus or same media. So media is shared, and all the stations available in the network will receive the message, whether it has been addressed or not. I mean, when this node or node 1 sends a message to the media, all nodes which are connected to this media, I mean node 2, node 3, and node 4 and node 5, all will receive this message. And all of this happens because of the fact that the media is shared. Access method or logical procedure to access the media is called CSMACD, or carrier sense multiple access and collision detection. We will talk about bus topology in detail in another video. But as an introduction, you need to know that the bus topology is the one that physical and logical topology are the same. I mean, whatever you see on the picture and what I said about the shared media represents the access method. So physical bus and logical bus are the same in this topology. The bus topology is designed in such a way that all the stations are connected through a single cable known as a backbone cable. Each node is either connected to the backbone cable by drop cable or directly connected to the backbone cable. When a node wants to send a message over the network, it puts a message over the shared media. All the stations available in the network will receive the message whether it has been addressed or not. The backbone cable is considered as a single lane through which the message is broadcast to all. Access method or logical procedure to access the media is called CSMACD, or carrier sense multiple access collision detection. It is a media access control used to control the data flow so that the data integrity is maintained. There are two alternative ways of handling the problems that occur when two nodes send a message simultaneously, which is called collision detection, which we will talk about in next video. Let's talk about advantages and disadvantages of the bus topology. Let's start with advantages. The first one is low cost cable. In bus topology, nodes are directly connected to the cable without passing through a hub or any other intermediary devices. Therefore, the initial cost of installation is very low, just a cable. The second advantages, which could be addressed here, is moderate data speed. Coaxial cable are mainly used in bus-based network that supports up to 10 megabit per second. Bus topology is familiar technology as the installation and troubleshooting techniques are well known and hardware components are easily available. The last one is limited failure. A failure in one node will not have any effect on other nodes. So let's talk about disadvantages of bus topology. First one is extensive cable. The bus topology is quite simpler, but still it requires a lot of cable. Difficult troubleshooting is another disadvantage of bus topology. I mean, it requires specialized test equipment to determine the cable fault. If any fault occurs in the cable, then it would disrupt the communication for all the nodes. When I'm talking about the cable, I mean the backbone cable, which all these nodes are connected to. Another disadvantage of the bus topology is signal interference. Because of having shared media, if two nodes send the messages simultaneously, then the signals of both nodes collide with each other, and we can say we have collision, which is a serious problem in bus topology. Reconfiguration difficulties. I mean, adding new devices to the network would slow down the network. Attenuation is another disadvantage of bus topology. We talked about attenuation in previous video, and you all know what attenuation is and how we could fix it. We can use repeaters to regenerate the signal. So these are all we need to know about bus topology, and we will talk about all of these topologies in detail in next videos. Let's talk about next topology, which is the ring topology. In ring topology, each device or node is connected with its neighboring node, forming the shape of ring. So it is known as a ring topology. The data circulate from one computer to another. The data flow in the ring topology is based on the token passing principle. So the access method or logical procedure to access media is called token passing. As you can see on the picture, all nodes are connected to each other and form a ring topology. Ring topology is somehow like a bus topology, but with connected ends. The node that received the message from the previous computer will retransmit it to the next node. The data flow is in one direction. It has no terminated end like bus topology. Each node is connected to other node and having no termination point. The data in a ring topology flow in a clockwise direction. As I said, the access method of ring topology is token passing, and it means we have a token which is passed from one node to another. And when a node have or receive token, it is like a permission or green light, and it says the node could send any information to the peer computer or next node. As you can see in the picture, the node 1 has the token, which is shown as a green star here. When node 1 receive token, it means the node 1 could send information or signal to the media. So node 1 sent the signal to the node 2, and because of having ring topology, node 2 would retransmit signal to node 3, and this procedure will continue to the stage that the signal would receive by the sender, I mean the node 1 would receive signal from node 8, and now the node 1 realize that the transmission of that signal is completed. For better understanding, I will explain this procedure, I mean token passing and sending information through the ring topology again. The token moves around the network and it passes from computer to computer until it reaches the destination. The sender modifies the token and putting the address aligned with the data. The data is passed from one device to another device until the destination address matches. Once the token received by the destination device, then it sends the acknowledge to the sender. In ring topology, a token is used as a carrier or a permission for a node to send information. As you can see, the physical layout of ring topology and the access method or logical topology in this specific topology are the same. The physical topology and the logical procedure to sending information are the same, and both follow the ring rules. Let's talk about advantages and disadvantages of the ring topology. The first advantage of the ring topology could be network management. Faulty device can be removed from the network without bringing the network down, and product availability is another advantage of the ring topology. Many hardware and software tools for network operation and monitoring are available, which is a good advantage for ring network topology. The cost is another advantage of the ring topology. I mean, coaxial and twisted pair cabling is inexpensive and easily available. Therefore, the installation cost is very low, and the reliability. Ring topology is a more reliable network than the bus topology because the communication system is not dependent on a single host or computer. Let's talk about disadvantages of the ring topology. First of all, it is difficult to troubleshoot. I mean, it requires specialized test equipment to determine the cable faults, like bus. If any faults occurs in the cable, then it would disrupt the communication for all the nodes, because the signal could not circulate over the ring network. Difficult reconfiguration is another drawback of the ring topology. Adding new device to the network would slow down or disconnect the network. The last one is delay. Communication delay is directly proportional to the number of nodes. Adding new device would increase the communication delay, since the data or signal should be sent from node 1, for example, to node 8, node by node. I mean, when node 1 wants to send a signal to node 8, the signal should be sent to node 2, and node 2 should retransmit signal to node 3, and then node 3 sent to node 4, and node 4 sent to node 5, and continue this procedure to send information or signal from node 7 to node 8. But as you can see in the picture, the node 1 and node 8 are close together. But because of having ring topology and sending information or circulate the signal in clockwise direction, the signal should send through all those stations to reach the destination, which is node 8. And this is all about delay, which would happen in ring topology. Let's talk about star topology. Star topology is an arrangement of the network in which every node is connected to the central device, which could be hub or switch. Hub or switch are mainly used as connection devices in a physical star topology. Every node is connected to these hub or switch, which is a central point of the network. The cabling that we use in star topology is twisted pair, and the access method of star topology could be CSMA-CD or token passing. As you can see, the star topology is a physical topology, and the access method or logical topology could be completely different from the physical arrangement. I mean, we can use bus access method or ring access method in this topology. As you can see on the picture, every node is directly connected to one central device, which I mentioned that could be hub or a switch, via a twisted pair cable or a fiber optic cable. This central node manages data transmission, as information sent from any node on the network has to pass through the central one to reach its destination, which is the hub or the switch. These central devices functions as a repeater, which helps prevent data loss and fix distortion and attenuation. Let's talk about advantages and disadvantages of star topology. Efficient troubleshooting is the first advantage of star topology. I mean, troubleshooting is quite efficient in a star topology as compared to bus topology. In a bus topology, the manager has to inspect the kilometer of cable to find the problem. In a star topology, all the stations are connected to the centralized network or device. Therefore, the network administrator has to go to the single station to troubleshoot the problem. Network control is another advantage of star topology. I mean, complex network control features can be easily implemented in the star topology. Any changes made in the star topology are automatically accommodated. Limited failure. I mean, as each station is connected to the central hub with its own cable. Therefore, failure in one cable will not affect the entire network, unlike bus or ring topology. Familiar technology is another advantage of star topology, as its tools are cost-effective. Star topologies are easily expandable. It is easily expandable as new stations can be added to the open ports on the hub or the switch. Star topology networks are cost effective as it uses inexpensive twisted pair cables. High data speeds is another advantage of star topology. It supports a bandwidth of approximately 100 or these days 1 gigabit or 10 gigabit per second. We could have 100 megabit per second to 10 gigabit per second network, which follow the star topology rules. Let's talk about disadvantages of star topology. The first one could be central point of failure. I mean, if that central hub or switch goes down, then all the connected nodes will not be able to communicate with each other. So it is also recommended to use multiple devices. I mean, you can use redundant switch or hub in this position to help network to be available. Another disadvantage of star topology is the cable. Sometimes cable routing becomes difficult when a significant amount of routing is required. Because of having specific cable from each node to the central point, we need to install cable for every single node in the network. So the amount of cable could be huge in the network with enterprise scale. Let's talk about mesh topology. Mesh topology is an arrangement of the network in which computers are interconnected with each other through various redundant connections. There are multiple paths from one computer to another computer. It does not contain the switch, hub, or any intermediary or central device which act as central point of communication. So we don't have shared media or shared connection. Every single node has its own connection to another node. I mean, if you take a look at this picture, you would see that node 1 has a specific connection to node 4 and node 5 and all other nodes through the network. So this is why the mesh topology is all about redundant connection. So mesh topology is mainly used for WAN or wireless network implementation, where communication failures are a critical concern. The internet is an example of the mesh topology. Because of having point-to-point connection between each node in a specific channel, we just have a physical mesh topology and we don't follow any logical rules here. So the logical topology or the access method could be anything because the connectivity between nodes are point to point. There are two different types of mesh topology. The first one is full mesh. In fully connected mesh topology or full mesh topology, each computer is connected to all computers available in the network. Another type of mesh topology is partially connected mesh or partial mesh. In this topology, not all but certain computers are connected to those computers with which they communicate frequently. When you take a look at this picture, you would see that we don't have specific connection between node 7 and node 2 because the node 7 and node 2 would not communicate to each other frequently, and when they need to send information or message together, they could use the connectivity between node 1. I mean node 7 could send information to node 1 and then node 1 could send those information to node 2. And if node 2 want to send information to node 7, it could use the connectivity between node 1 to node 7, and if the node 1 has any problem, the node 2 could send the information through node 4 to node 7. So as you can see, we have redundant link here and redundant pathway to send information, but we don't have specific link between all those nodes in the network like full mesh. The number of connection that we need to form a mesh topology, I mean the full mesh topology, could be calculated by this formula, where n is the number of available nodes in the network. So when you put the number of available nodes in this formula, it will give you the number of connection that you need to have in the network. Let's talk about advantages and disadvantages of mesh topology. Reliability is the key point of having mesh topology. I mean, the most important advantage of mesh topology is reliability. The mesh topology networks are very reliable, as if any link breakdown will not affect the communication between connected computers. And because of having redundant link to send information to our destination, we barely have downtime in these kinds of network. Communication is very fast in mesh topology since we have specific channel or connection between all those nodes together. On top of that, adding new devices would not disrupt the communication between other devices, and it's easy to reconfigure. So let's talk about disadvantages of mesh topology. The first one is cost. A mesh topology contains a large number of connected devices, such as a router and more transmission media than other topologies. As you can see, we need lots of connectivity between nodes, and in comparison to all other topologies that we talked about, we need more cable or connectivity to connect these nodes with this topology. Management is another issue that should be addressed here. Mesh topology networks are very large and very difficult to maintain and manage. If the network is not monitored carefully, then the communication link failure goes undetected, and it takes lots of effort to find and fix the problem. The last one is efficiency. In this topology, redundant connections are high that reduces the efficiency of the network. And this is why we use mesh topology in networks that are critical and very important. And it's not economical to use this topology in computer network that we have in our enterprise or LAN network. And most of all, we use this topology in very important network, like networks that we use in emergency cases, networks that we use to communicate between airplanes, and these sort of things. This was all we need to know about network topologies, and I would talk about these topologies in detail in next videos. So this is the end of this training video. Don't forget to like, share and subscribe, and I hope you will find this informative and useful, and I would like to thank you for watching.